Good morning all, and let's see this problem. A is a fixed real number so that there exists at least two values of x in the interval such that the function f of x given in LHS, because clearly this is a function of t, and if we'll integrate 0 to x, so let's say if it is some f of t, by integrating from 0 to some particular value t equal to x, we'll get an area which will depend on x, right? So this LHS is a function of x and RHS is a fixed quantity. So f of x will be something like this, let's say, roughly. And RHS, it gives some constant for a constant value of a. So we need to show that the given equation will have at least two solutions, at least two real solutions. Now that is very crazily good question, and a lot of learning is there in question. Usually you'll not find these questions again very easily in your JEE preparation. So please do like and subscribe the channel if you have not done so, क्योंकि इसमें काफ़ी effort it takes to like come out with these questions. And moreover, many teachers are not also willing to release these kind of questions because they feel their content should not be like easily available. So please justify the effort, and let's solve this problem now. So first you must have noticed something is as if this function sine of pi of, if I'll write sine pi t by 2 over 2. So the first observation is this feels to be very intimately connected with this expression, right? Because it's this versus 2 by pi arc sine means sine inverse. It's 2 by pi arc sine means sine inverse t, right? So it feels like they are closely connected. It's not very difficult to notice. And the first observation is observe that they are inverse of each other. While inverse, so let's take this as y. So I'll get sine inverse y equals pi over 2 sine pi t by 2. And then again we'll have 2 by pi sine inverse y equals sine pi t over 2. And if we'll further send that side, so we are getting sine inverse 2 by pi sine inverse y equals pi t by 2, and that goes to 2 by pi over here. So clearly we can see if this part is f of t, so this is going to be some f inverse t, right? So with this motivation, now we are ready to tackle this problem roughly. So what we can tell is the given expression, if I define f of t as sine of pi sine pi t over 2 divided by 2. And now we know the function is bijective in the interval 0 to 1 to 0 to 1, because 1 1 on 2. Hence the existence of an f inverse is guaranteed. And f inverse also exists within the same interval 0 to 1 to 0 to 1. Why I'm interested in 0 to 1? Because the question tells then there is at least two value of x in the interval 0 to 1. So I'm interested in x 0 to 1. It means the maximum bound of integration is up to 1. Okay, so in that window we are interested in the problem statement, right? So armed with these techniques, now we are ready to like tackle this problem. So let's denote f inverse t as gt. And now you can again observe RHS as well, because this expression is 2 by pi arc sine inverse is actually same. So it's a value evaluated at is g of a, and this quantity is nothing but f of a if I define ft and gt in that fashion, right? So now I can manipulate the given expression, and the given expression is nothing but it can be written as 0 to x ft plus gt minus 2t dt equals half times a minus g of a, because g valued at a, times f of a minus a, f of a minus a. So based on the first observation of function and its inverse, the next point was to observe the RHS and write it in the same fashion. So now the question boils down to this. And now we are interested in finding number of solutions of this, or in fact here, for any particular value of a which is lying between 0 to 1, we need to show there is at least two value of x lying in this interval, right? Okay, so how to go about it? We can see a geometrical aspect of this, because let's say if I draw roughly a graph of function f of x. So let's say this is f of x between 0 to 1. So clearly its image, then we have g of t here, and we have the line y equal to x, like y equal to t, where everything is reflected, right? Now, what is the physical significance, or geometrically, can we try to decode the meaning of ft plus gt minus 2t? That's not very difficult, because you can see here, if I take any point, let's say t over here, the height of the function, so this height over here, basically represents f of t. What about g of t? G of t represents this height, right? So this height is gt, the total height is f of t. If I'll add f of t plus g of t, that is going to give me, okay, so since both of this function is already depicted over here, so we know f0 is going to be 0 and f of 1 is 1. Exactly in the same way, g0 is 0 and g of 1 is 1, and that I have seen from the definition of this function f in t. And now you can see a very interesting result. The LHS value, and now we can see the very interesting result. The LHS value can be written as ft minus t minus t minus gt, and that's going to help me in a great sense, because I can geometrically represent this quantity in the xy plane. So let's decode ft minus t value 0 to x. So let's say we have 0 to x. So at any point 0 to x, ft minus t represents nothing but area bounded by the curve ft minus y equal to t line, right? Now out of this area, we need to take away area bounded by t minus gt. So y equal to t is this line, and if I'll take away gt, which means this area chunk, now you can clearly see, like out of this hashed area, we have to take this green divided by, so we can clearly see now we have to do green minus this reddish area. Now this red area, this chunk is exactly same as this chunk because of the symmetricity of y equal to x. Hence finally what we got is LHS is nothing but the area of the chunk between this two horizontal and vertical line and the graph of f of x, right? So finally the takeaway is f of x is nothing, if I denote this entire LHS as some expression, let's say capital F of x, so f of x is nothing but simply area of this chunk, right? And let's say if I start sliding x, so if I start sliding x over here corresponding to this, I'll get this as the area. So this is the value of f of x for this. What if x becomes 0? And definitely the slider will become a point and it will cover no area. So by the very definition, f0 has to be 0, and that is clear from this definition also, because the integral will be 0 to 0 something, so that will simply die. Similarly, interestingly, we can see what is f of 1, and f of 1 is not easily visible from this diagram because 0 to 1 this expression can't tell you. But let's say if I take 0 to 1, so if I take the extreme position for x, then still in the limiting case as it goes further, f of 1 has to be 0, right? So we know we have a function f of x which is defined at 0 to x, f of t plus gt minus 2t dt, and we have seen the geometrical interpretation of this with f0 as 0 and f1 as 1. Now let's check the geometrical interpretation of RHS as well. So clearly it feels like half into base into height. So let's see fa minus a at any particular value of a. Fa minus a is just this side because we have total f of a, and take away the height of the line y equal to t. So this size is basically fa minus a. Similarly, a minus ga, exactly with the same logic as before, is going to be this distance. So half into a minus ga into fa minus a is nothing but this area of the hashed region, right? And for a particular value of a, let's say if a is half, so this area will be fixed. Similarly, if a is 1/3, so area will differ, right? So it will keep on changing. So let's say for this a, I'll exactly have this shaded region as RHS. And now it's an interesting case because LHS and RHL is, and now it's an interesting case because RHS and LHS is very closely related. So we have a function f of x, and now you can see f of 0 is going to be 0, and at extreme point f of 1 is still 0, right? So we have f of 0 0, f of 1 0. So the graph must do at least one bending. So in that case, if I have any area between 0 to 1, and every area from the continuous function will be achieved. Okay, so any area between 0 to 1, let's say, will be achieved at least twice because we'll have minimum 2 points of intersection always. And this follows from the continuity of the function. So I hope you enjoyed the problem.